All right, Lady Ada, what is this?
Hi, everybody, and welcome to Show and Tell. It's me, Lady Ada, with me, Mr. Lady Ada. We're broadcasting from Brooklyn. Going to check in. We got these cool new mics. We're checking what's going on in the maker community. What are people hacking, coding, soldering, 3D printing, DMXing? We're going to find out. Let's just see what they're up to for the next 30 minutes, and then ask and share.
Yeah, we're going to do Ask Engineer at 8 o'clock. We're in the holiday season and more. Lots of show and tell folks coming by with projects, including our Adafruit staff. Brent, what is going on this week?
Hi, your microphones sound really good and clear.
Yay!
Yay!
Yeah, good justification, and they look cool too.
Yeah, they
look so cool.
Yeah.
Yeah,
Like
so
Star Trek.
the past few, I guess the past month, been working on this like offline mode for WipperSnapper, and on my desk I have I'm trying not to unplug it, a Metro ESP32S3, and I failed on not unplugging, but it's okay because it'll just restart.
Yay!
And it has a DS18B20 connected to it, and RTC that's like dangling off board. And it's running this new mode of operation, which is called offline mode. So in WipperSnapper currently, you can only be online. So you connect to Adafruit.io and configure everything from there. But this takes it backwards, and you configure everything first. And then we give you this really neat like configuration file, and it tells you it's human readable. So you can tell there's an analog pin.
Do you want to share it?
Oh, is it not sharing?
Yeah, let's share.
Yeah.
Sorry.
Now it is.
Okay.
It wasn't sharing.
Well, I didn't hit.
Well, but you weren't really like.
I didn't hit the.
You had just started
I
talking about it.
I didn't hit the button.
Oh, okay.
Okay,
sure.
So it's human readable. Yeah, they're like, oh, this.
Yeah.
Yeah.
So like, there's this file. Like IO will generate it, and then it'll spit out this like file, and this file sits on the Wipper drive. And then when the device boots up for the first time, it actually notices like all of these components, and you can configure as many as you want, and it decodes them and automatically sets them up and starts logging. So it sends like data immediately to the serial, which is cool. So these are like JSON. This is like a file format called JSON-L, so they're JSON lines. So they're a streamable file format that's not CSV, so parsing isn't difficult. And if it stops in the middle of it, it's obvious. Like this is a defined file format. So it includes a timestamp from the RTC, the pin, the value, and the SI unit of each measurement. So like if, for example, we're measuring both Celsius and Fahrenheit from the same sensor. So if you unplug the Metro and then you like pop out the micro SD card, and you put it in your reader, and then you plug it into your computer. The Open Finder. There's a ton of log files on here because I've been testing this, but we could find the file it was probably writing to before.
Nobody's gonna know. Just open up any of them.
Sure. So this is the one that wrote really quickly. And it shows each value on its own line. And I've also been able to like pull this into Google Sheets. So like this is your data. It's not going to the cloud. It's sitting on the SD card locally, which is really neat. And some of these are really large. Like this is a 400 byte file, or like this is like there's some like much larger files on here as well. And these like have run overnight and gathered data, and then like you can take these, you can put them into like Jupyter, you can put them into MATLAB, you can put them into like Google Sheets, and like plot them or graph them or do any type of like data manipulation you want on them.
We talked for a while about like what's the format. We're like, should we do CSV? And then we're like, you know what? Let's do this JSON-L, like one line JSON, because you can always take JSON and convert it to anything else, but CSV can get corrupted and confusing very easily. I like that this is like easily readable and easily parsable. It's kind of but I mean, it's like big, but so what? SD cards are huge, so like it doesn't matter.
Yeah, and then I added handling this past week as part of what I was working on for like splitting it up into multiple log files based on the capacity of the SD card. So like even if these files do grow, they won't overflow. They won't be too big to parse. They will actually start splitting up.
Oh, that's a good idea.
Yeah.
Smart. Okay, cool. All right, I'm digging into offline mode. It's cool. It's like a natural evolution of WipperSnapper, I think.
Yeah, and I think it will. I have a friend who like does GIS work, and he was like, "Wow, I work for a company in Cambridge, and we threw like these sensors in the river, and it was really complicated And it's similar to what you're doing, but this is so much easier. I was
Yeah.
like, oh, that's great. You completely understand what we're doing, even though
Good.
it's not published yet.
Yeah.
The application is there.
Okay.
All right, thanks so much,
All
Brent.
right, cool. Thanks, Brent.
Next up, let's go to JP. JP, what you got going on?
Hey, I got glowy pixels.
Ooh, hearts.
Yeah, we got our hearts and our spheres, and I didn't put the stars up, but I have just a strip of NeoPixel hidden under some coroplast there. And the neat thing is that this is running off of a DMX controller, which you can see here. And if you watch the pixels behind me, right now I've just got a few different scenes programmed. So this is usually how theater lighting is done, is you'll program cues for different moments or scenes.
So like purple, rainbow.
Yeah, so I've got different controls on 3 different strips running off of DMX. There's 8 channels that I'm dealing with, so I'm basically setting the hue, saturation, brightness, and position of 1 pixel as well as another pixel. And I'll switch back to Big O Vision here because it's more fun to see the big glowy pixels. The neat thing is that with this, I can do, hand tuning of the 3 strips from the controller, and I can do pre-programmed scenes here, but I can also just have it run automatically through those cues. So if I just hit auto here, it's now going to run from cue to cue to cue on its own, just on a timing. And you can do this with, have it set to music or whatever. But you can see that it's actually like an automated fader. It's not just jumping to a set pixel. It's as if it's flying the fader from 0 to 255 or anywhere in between. So you get kind of free, neat transitions between just a few presets there. And that's running on like a $40 mix controller.
So you've got like the Arduino, and then it looks like you've got like 20 of each pixels. So each one of those is a DMX light. Is it like you have 3 universes or 1 universe with 60 lights?
I have 1 universe, and I only have 3 sets of 8 channels being used, because since this isn't DMX, but it's NeoPixel over here, by the time my DMX gets to the Arduino, I can do anything I want with it. So I've simplified my life, and as soon as I receive a DMX call for 1 pixel, I can then do some math to interpolate between the other. So I'm only setting the color of 2 pixels, and then I'm letting my Arduino code do the little between.
So on like the hearts, there's like you're only setting the first and last pixel.
That's right. Yeah. So I just switched on my controller to the hearts channel. So if I go and change the beginning position and end position of the hearts, those are just 2 sliders. And now I can change the beginning color and the end color of the hearts, and then the other stuff.
What are you using to interpolate? Is that fast LED or fancy LED?
No, it's just me asking ChatGPT, and it's saying use lerp.
Okay.
And so it's just doing a nice linear interpolation between.
That's fine. No, it's cool. I mean, I'm just like,
This is neat because it's combining 2 different worlds.
Yeah.
NeoPixels.
It looks really great. Like it came out really nice.
Yeah, this is I'm excited about it because this is the sort of thing where, unless someone like manufactured the exact thing you want and you're in the DMX world and in the theater world, you just don't get this much choice. But since we can get it over to code with a little DMX shield there, then you can kind of do anything you want. Like I originally was doing red, green, blue, but I was like, you know what? I just want hue, saturation, value, because I mostly just want to slap hue around because that's cooler, and I don't have to like hand tune red.
No, as humans, we deal with hue, saturation. Like HSV is much more natural than RGB, which is like you're like, what is? It looks like it has a little bit of green, a little bit of blue, and more red. Like you're not going to know, but you know if it's like, where are you in the color sphere, and then how deep is the color and how bright is the color.
Yeah, and a thing that I almost never do if I'm dealing with RGB is mess with saturation. But if you want like subtler, pastel-y kind of colors, saturation's where it's at.
Yeah.
Like you don't really find yourself in that kind of color world when you're doing RGB.
And that's easier for like mood, because you're like, okay, these colors have a certain mood to them.
Yep.
Okay.
And I can tell all 3 to run together if I want. Like the DMX controllers are set up pretty well to do. If I switch this controller or this camera real quick back over, here I'm saying strip 1, strip 2, strip 3. So if I set them all, you'll notice my strips are all going to react together.
Okay.
This is also a great like way to use, off-the-shelf controllers for NeoPixels, because you could build something to control NeoPixels like that, but like that's like not so fun. But this is just like get it, like you might have DMX stuff laying around, or like,
For sure. Yeah, it's such commodity hardware, and
yeah, it's been around forever.
All right,
tons
cool
of
stuff.
it.
All right,
Thanks,
good
JP.
stuff. We're in the intro for Ask an Engineer and the outro. I'm going to play the 2 videos. I can decide which one I like more, so I'm just going to play both.
Super. Thanks so much. Yeah.
All right.
All right, JP. And folks can see you
Yeah, come on by tomorrow for the show. We'll goof around with a little bit more of this and look at it in a little more depth in the code, and then move into some other projects for the end of the year.
Yay. All right, nice. Thanks, JP.
Thanks, JP.
All right, Jepler, what do you got going on?
Hello. So I
got
have
Brent.
NeoPixels.
Yeah.
They're really a great holiday gift. But what I have here, and my cable is short, so I can't really get it up to the screen. This is a Pi 5 with a Braincraft hat on it, which was just convenient for that D13 connector, and it's hooked up to an LED strip. And up to now, my understanding is we couldn't do these NeoPixels with the Pi 5.
That's right.
But Raspberry Pi released some sample code for interfacing to the RP1 chip, which is on the Pi 5. And it turns out it's kind of similar to the RP2, the RP2040 that we know and love. And it has a PIO peripheral in it. And now they're letting us run PIO code. So I've written NeoPixel for Raspberry Pi 5. And as you can see in the code, all you say is import NeoPixel.
Ooh.
And then it works with everything, quote unquote. I mean, I've just tested it with LED Animation Library, but that was pretty much
big deal, because people have been waiting years for this.
Yeah.
How long has the Pi 5 been out?
About
I guess a little while. Yeah. So the code is on GitHub. We still have to put like a very short change in actual Adafruit Blinka, but you can check that out. And after I get done talking here, I'll drop some links into the Discord. But look for that soon, the ability to run NeoPixels on Pi 5 along with all the other goodness that Pi 5 brings.
Good work, all of us doing Blinka stuff too, because you get everything with this.
What I like is you can pick any pin.
Yeah. You can just use any pin there on the Pi 5, and you might be able to do 2 strips. I don't know. Haven't tried it yet.
Even one though. I mean, the historic.
Even one. This is great. It's very stylish. Everyone will be wearing one.
That's right.
Yes.
So we're working on more stuff. We're working on something more like the state machine class that exists in CircuitPython for the PIO. And we might be looking into RGB matrix, but don't hold your breath, because it'll be a little bit. But this is what we're looking at, because we want to get all those things enabled on Pi 5.
I mean, that's a big success.
Yeah. Well, I have to really thank the Raspberry Pi folks. They furnished this code, and the API is almost exactly like it is in the Raspberry Pi Pico SDK. And there's been nothing weird. Like I wrote the code and it worked. And the time it didn't work, it was my own uninitialized variable that stopped it. So it's really been pretty smooth sailing. And I want to say thank you for that, because without their work, we just wouldn't be able to do this. We'd still be scratching our heads and wondering, how does it work?
You wouldn't have such a glowy neck.
Yeah.
Yeah.
Well, this is why it's like, the fun skateboarding culture world of electronics and coding. They did a trick, we did a trick, and now like we're building each other up. Speaking of, for folks who haven't tuned into our retro computing Advent Day celebration, check out Jeff's story, Dan's, and more. Jeff has amazing computer history knowledge and more that you probably hear about sometimes or see. And there's some stories, and there's a bunch of old cool computers that I think you can learn a lot about the future by looking how we got here. So
yeah. I started in the 8-bit era, and Dan started a little bit before I did.
4-bit, 1-bit.
Cool.
It all worked out,
Cool
because
stuff and cool history.
Yeah.
But my story is just instant addiction to computers, and here I am 40 odd years later still doing computers.
But earlier, I think if you went back and showed younger you what you were doing, that younger you would
be like, that worked out.
I think so. They totally would be.
Yeah,
they'd be like, that's sweet.
Like, cool. I'm gonna just keep at this. All right. Thanks so much, Jeff.
Have a good evening, y'all.
Yeah.
Thanks, Jeff.
All right. Now, what you got going on?
Hey, folks. Yeah, so I have some .star LEDs, they're flickering, so kind of a warning if those bother you. But why would we use .stars LEDs? Well, one of the great things about .star LEDs is that they can blink really fast, and with that, you can do a POV or persistent vision effect. So we did a couple light painter projects a couple years ago, and I thought, well, it's time to put a motor on a thing
We can
and
do
have
it.
the LEDs
We got motor.
spin. Yeah,
Spin
so we
that.
got motor. I came up with this kind of design that has the motor on the side here with these gears, and then the slip ring really makes this possible. So the slip ring is this kind of wire harness that allows you to have wires spin freely as long as you want them to spin, and they don't tangle up, which is kind of magical, really. So I'm going to turn it on now, and we're going to see what image this comes with. I'm going to stand up too, because my body's going to be kind of like a background.
I like that you figured out that you have to put like a piece of string to not have the thing spin apart. That's fun.
That is funny. Yeah, this is a little piece
I like
of nylon string. Yeah, so
you can tell that wasn't there when you started the project, but then it's like I got to put something.
I got to put some string on this.
That's exactly
Okay.
So let's turn it on.
Get it out.
So it's in CircuitPython. The CircuitPython code takes a bitmap image, and it kind of turns the image into these blinking lights.
Yeah, and you can see that over a camera, over the internet, over.
Yeah, it's really hard to capture this. So it's nice that that you can kind of see the image there.
Are you going to do some like light painting type stuff with like opening up?
Oh yeah, totally.
Camera?
Yeah, totally. This is just V1. We definitely want to do a V2. Where we can change the image on the fly, maybe have bitmap, animated bitmaps would be really cool. And for version 3, it might be a little too much, but maybe we can get it to play Doom.
Yeah,
that could be a fun thing. You got to have
animations.
Doom somehow.
Doom.
You know, there's those really dangerous, high-powered spinning blades that have LEDs on it that you see a lot of on Taobao or whatever. This is like the safe one you can build yourself, but still probably get a lot of the same effects.
Yeah, for sure. Yeah, you can put it together, and the motor's not too dangerous. It's only spinning about 200 RPM, so it's not going to like snap your fingers off, which is nice.
Yeah, those other ones are like, we got to put it in a cage or like keep it up.
Yeah.
All right, outstanding. So folks can tune in probably to 3D Hangouts.
We did a whole deep dive yesterday on the design. I learned a lot of new things. Of course, the slip ring is really cool, but I also 3D printed the ball bearing that allows the thing to distribute the weight really nice. So that's cool. I haven't done that yet, so that was nice.
Yeah.
So we're getting really good at spinning things. So got to spin those LEDs.
Nice. All right. Well, thank you so much. And folks can tune in to Ask an Engineer. We're catching up with some videos so you can see some fun 3D printing projects and more. Thank you so much.
Yeah. Thank you, folks. Have a good night.
Everybody.
All right. That's our show for tonight, everyone. Thank you so much for joining us. Don't forget to come by every single week, 7:30 p.m. Eastern time, where people show and share their projects, retro stuff, art, science, history, you name it. It's been on the show and tell. We'll probably be doing
lots of LEDs today.
Fun ones over the holiday and more. See everybody next week.
See everybody.
Bye-bye.
Bye.
Oops.
Bye. Bye-bye.